Hello everyone, my name is Temkeen, and in this tutorial I am going to show you how to build a parametric circular facade in Dynamo and visualize it directly in Revit. We'll start with a simple circle, divide it into a number of points, place 3D blocks on those points, and then turn the whole thing into a twisting vertical form that sits on a floor. I'm starting in Dynamo with a new empty graph. In the library on the left, I search for circle.byCenterPointRadius and drop that node onto the canvas. Next, I create a code block node and type 1000. This will be my radius for my circle. I connect the code block output into the radius input of the circle.byCenterPointRadius node. To place geometry along this circle, I need to coordinate systems at different points around it. In the library, I search for curve.coordinate_system at parameter and place that node. I connect the circle output from circle.byCenterPointRadius into the curve input of curve.coordinate_system at parameter. I want to control how many elements I have around the circle, so I'll add this number slider. I connect the number slider output to the input n on the code block, and then connect the code block output to the parameter input of curve coordinate system at parameter. In the preview, you can see a ring of purple points and small coordinate systems distributed evenly around the circle. Dragging the slider up and down changes how many points we get. With the coordinate system in place, I can now add geometry. In the library, I search for cuboid.byLength and drop that node onto the canvas. I connect the coordinate system output from curve.coordinate_system at parameter to the origin input of cuboid_by_length. To make the system more intelligent, I want some of the block dimensions to be driven by the length of the circle and the number of elements. I search the library for curve.length and place that node on the canvas. I connect the circle output from circle.by_CenterPointRadius into the curve input of curve length. Here, A will be the curve length and B will be the number of elements. I connect the curve.length output to A and the number of slider to B. Each of these code blocks is connected respectively to width, length, and height on the cuboid_by_length node. In the preview, Dynamo now shows a ring of vertical rectangular blocks following the circle. Increasing the slider increases the number of blocks. All of them stay evenly spaced. I'll translate the cuboids upwards. From the library, I search for geometry.translate and drop that node onto the canvas. I connect the cuboid_by_length output into the geometry input of geometry.translate. Then I create another code block to generate a series of vertical offsets, something like a sequence multiplied by a height factor. And then I can multiply that list by a story height in another expression or inside the same code block. I connect the resulting list of values into the Z translation input of geometry.translate. Now, instead of a single flat ring, I get a stacked rising pattern of cuboids, a kind of twisting vertical shell. Because everything is driven by the circle, the slider, and these formulas, I can experiment with different number of elements, radius, and height, and the whole form updates automatically. At this point, I orbit around in Dynamo's preview to check the form. You can see the cylindrical or partially open shell made up of repeated vertical columns. Adjusting the slider changes the density of the columns. Changing the radius value in the first chord block changes the overall diameter of the form. Tweaking the formula that uses curve dot length changes how stretched or compact the columns appear. Switching back to Revit, I want to give this parametric shell an architectural base. I open Level 1 Floor Plan, and under the Architecture tab, I choose Floor to create a new floor boundary. In Sketch mode, I draw a circle that goes outside the diameter of the shell. Click the green checkmark to finish the floor boundary. Revit generates a circular ring-shaped slab. Switching to the 3D view, I can now see the circular floor at the base with the Dynamo-generated facade rising above it. The vertical columns wrap around the perimeter, forming a twisting cylindrical mass. Because Dynamo is still driving the geometry, I can go back to Dynamo at any time and adjust the radius, the number of elements, or the heights formula, and the Revit model updates to reflect those changes. That's the complete workflow, starting from a simple circle in Dynamo, distributing coordinate systems along it, placing cuboids at the coordinates, using curve length and sliders to control the spacing and height, translating the geometry into a vertical shell, and finally grounding the design with a Revit floor. You can adapt this setup to create different kinds of parametric towers, facade, or atrium walls, just by changing a few values and formulas in the graph. This completes my presentation, and thank you for watching.